Hello guys. So today I solved D prefix permutations from educational Codeforces Round 142 and the 1700 rating. So I will discuss this question and then I will discuss the solution. Do if you like my videos, please subscribe to the channel. It will be help me to explain more videos and some motivation. Follow on Instagram also. There we will add up some tricks and tips for coding. So now this question is you are given that like in this question we are given one permutation a2 a3 a4 a5 up to an. So this is the permutation and like permutation means like suppose one if permutation is given means 1 to n there will be numbers only. There will be no doubles or no triples number, only single number. And this is a length of m. Like there are n permutations, n like n different permutations. Like there will be 1, 2, 3, 4 up to n. From 1, 2, 3 to n. There are n permutations. And everyone will be having from 1 to m. 1 to m. So this is the initial condition that the permutations are from this one to this one. So they are saying that the beauty of permutation, how we will calculate the beauty of permutation is like the sequence where the indices will be like maximum indices where up to that the below are the equal. Like suppose 1 is here, 1 indices equals to 1, 2 equals to 2, 3 equals to 3. This is the indices and this is the value. So they are saying that it will go up to that position where the indices will be equal. When the indices will be not equal, like here will be 6, here will be 5, this time the indices will be not equal, then the length from the 1 to up to that indices will be the beauty of that permutation. So it is saying like this way, we need to find that one. And suppose initial condition is also 0, like initial at first position the value is not equals to 1, then beauty of that permutation will be 0. So this is the half part of this question. Now they are saying that we can change the, now we need to use this we need to update the permutation. So you will take pi any not p, you can take p and p multiply by q, which will result into a new permutation. So in this new permutation the updated values will be rj equals to rj equals to qpi, q and pi. So now and for each I, from each I to n means like this is the like pi, you can choose pi, this pi for this q from 1 to n, 1 to n, 1 to n, and I equals to j also, you can choose this one also, like p into p also. So we need to choose such a p where it will give us a maximum value. So for every I from I 1 to n, we need to find that value, that what will be the maximum, and we need to print the output according to this one. Now pause the video, think your approach, think about solution, and if you are done, it's okay. If you it's really good. If you're not done, just go through tags so that you can use binary search, bitmask, data structure, hashing, math, sortings. You can use, and I will tell one more data structure which will be easy to implement, and question will get solved. That question is accepted. I solve by that way. So let's go and solve by my method. So first is like the converted p into q will be changed into r q pi. So here remember, here pi is here, right? So pi is this one. Suppose we take example of any first example, 2413. So for 2413, so suppose q is this one, right? And we need to choose such a p which will give maximum beauty for this one value. So let's first observe this thing. To get r, this is the one of first, like there is only one observation, only one observation in this question, that qpi in this one. Suppose for getting any maximum value from starting from 1 to that number, you should, the first number should also always be equals to 1, second number should be always equals to 2, third. So for going forward, the previous number should be equal. So if you want to go further, like if you want to go this side, then whole number should be get equal, then and then only you can get this 4 value. If 3 is not equal, then you will never come to this position. So first observation, that we need to make this r is such that this value means like r1 equals to 1, r2 equals to 2, like this way we need to form. So we need to form by this way. So we need to check which values will give this value r21, because as a permutation there will be all numbers, 1 to m there will be all numbers. So now in this question, r equals to, I will write q p pi. Just think, suppose in first position we need to fill 1. The first is q equals to 2413. Now at r equals to 1, we need to fill equals to pi equals to 1. We need to fill 1. Now let's check when the qpi will give 1. When the value of this one equals to 3, means like pi equals to 3. When pi equals to 3, that time it will give value as a 1. Similarly, when qpi will give 2, when the pi value equals to 1. So from that we are getting to know that the position of that value initial itself gives the respective values, like pi, when the pi equals to 1, when pi, like we will update pi here, first position will be for this one we need to 3. For second, to get second updated at this position we need 1 at this position. To get third at this position we required 4, because when q4 will be replaced with this value we will get 4. Now similarly last one, which will give 2. So this will be the required pi which will fulfill this condition and we will get. So we need to check which p will be the maximum close to this value 3142, and that we will take that value and we will update that answer, because this will be the answer out. So this was the logic, and in this logic I guess you got the idea. Pi, in which we will try to find out pi. So now let's see, 2, 4 and 1, 3, right? 1, 3. Let's indices 1, 2, 3, 4. So this is your q. So now the required p to get maximum value is, the first indices is 3, then second index is 1, then third index is 4, and the last indices is 2. To get maximum value of this value, you require values which will be closer to this value, p's value which closer to this value. From this we are getting that we need to form the values according to this value. So for that reason what I used, so I used try here. There's one concept, try. I will go to my code also. So I used try. So in this try, what I did, see, only things you need to consider that to select any p, you need to check the indices. These indices you need to consider in your calculations. So we are only considering this indices, and we are forming p according to from this indices, like this. From this we are forming p. From this q we are forming p. Similarly, we will get another p's also. Similarly, we will get another p's from this one. So we need to only for this value, this q, for this is the given q. Okay, so this, from this q we will search for p, whether this p exists or not, 3142, and we will get the value. In try what we do, in try what I will do, this is the root value. So in this one I'm considering one structure node in which there is up there, it is mentioned that there will be 1 to 10 only, the yum will be smaller than 10, up to 1 to 10 values only. So what I did, I created up to 10 children's, up to 10 children. Suppose you can assume like this way, in this what I am doing, suppose at first position, if you want anything, like for your one should come at third position, like we previously calculated these values you required, that one should be come at this position. So what I am doing, for one like this is the first value. So I will check whether any of this given out of 10, third position, whether any of the given arrays permutations, there is any position where one exists at third position. I will check whether at third position any one is exist. If it is exist, we will go for the next position, we will go for the second from this one. For this one also we will create its 10 children's. And similarly there will be a tree structure, like there will be one tree, there its own children's, then its own children's, like there will be own children's, like this way you will form one tree. So basically what I am doing, from this one I am forming one tree, it is node and it's tree which having 10 children's. So this is the tree which we are forming. Now what I will do, I will explain code now. So here we are just I shared you that how the node is forming, like there is a children which will be parallel to this one, and there is count variable, like how many values are going down, like this one value is going down, this one value is going down. Now what I'm doing, I'm taking the input as num, then value num, then I'm just creating one root initially which are having 0, like suppose you can assume it will be 0 value, it will be 0 value. Wow, it is not color changing. Yeah, it is 0 value. And now I'm just first time I'm created 10 positions. So what I'm doing, I'm pointing one pointer at temp, like root as a temp. So here I'm just checking that like in first what I'm doing, suppose in first there is one, like what the answer, 2143, right? So first what I will do, I will make p for all the values, like here I am making. So firstly I will find out the indices of every, like I want first indices. So from this one I'm just making 1 2 3 4. So I'm making 2 1 4 and 3. This is the P which I am making for this Q. For this Q, the P should be this one to get the maximum value. So from this one, I am making P. So this P may be useful for the next one, next any value, or this P will be useful for this Q itself. So for that reason, I am just making P of everyone. So I am taking indices. Firstly, I am taking the input as usual and just storing that values with respect in map. I am just storing that value with respect to their indices. Then what I am doing, I am going to temp this temp. I am going to temp this root value, means like pointer one created at temp root. So I am checking at first position. I am checking at first position. Why this tablet is not working? In first, I am just checking whether that first value, like there are 10. Why today is creating a lot of problem. So this one pointer is there. So these are the 10 places, 10 children of temp. So I'm checking. So like first position is in this one. Suppose in this example 2 1 4, this is the Q, this is the P. So P which will form here will be 2 1 4 3. So in this I will check 2. Sorry for the disturbance. So in this one, for 1 I will check that first 1's position, like that 1's position is at 2, like 1 2 3 4 5 6. At 2, whether there is 1 counts or not. So it is 1 if there will be 1, like there will be 10 children. So in first we will go to the first child. We are at first child. So we are checking that for first, at second position, whether the children is created or not. If not, we will create one children. We will create one node. Like if suppose first there in initial there is no any node, so we will create from second we will create one node like this one. Then what we will do, when we come to 2, that time we will update this value by +1. We will add that position, like at this position at 2 in one permutation 1 exists. So we will add up it, and then we will move to the next, like we will move to the next one. Temp will be updated to the next, to the 2's position. In that, what we will do, we will update the first position. We will update that first position and we will mark it as a 2's position. That for 2 value, to update get a 2 answer, we have 1 at this position. Like after 2, in one permutation, if we choose this permutation, we will get 2 for the second from this permutation. Similarly, we will make next one. We will continuously do and we will update these values according to their positions. Now, when we will do all this for everything, what we will do, just we will count, like we have tree like this way. Then there are 10 childrens at first position. We are going with level wise, okay? Remember this thing, there are levels. Like this is the first level, means like first one. Then this is the second one. Second one, there will be 10 options. Like this one, 10 options. Then third, like this is the only 10, so it will be 10 into 10. It will be in like this will be insufficient memory. So we are just checking whether like this one will be here, 2 will be here, like this way, positions from 1 to 2 where we are going. Now what we will do, we will check for this one, for these values. What we will check, we will check whether, now we will take example 2 1 sorry 4 3. Now what we required, we required in any permutation, like this is the queue, in any permutation we required first at this position, at second position, sorry, my mistake. We required 2, we required 2 at this position, we required 2 at this position, like for on first position we required 2. Sorry, my mistake, I'm not able to tell clearly here. So here, now let's think, this is the queue, this is the queue. So let's think, to get R equals to QPI, I will use black color. To get R equals to QPI, to get this one equals to 1, what happened? To get this equals to 1, we know Q equals to, when will be the value of 1? Value of 1 in Q is equals to this one, this condition, then Q equals to 2, equals to 1. So at the end, when this value, this indices, like when Pi equals to 2, like Pi equals to 2 and that Pi value will be equals to 1, like any permutation in which the second value will be 1, this one value will give us the answer R equals to 1 at first position. For this one at 2, for 2, let's check when this value will be 2. Now in this question, when Q1 equals to 2, that time we will get the answer as a 2. So Pi should be equals to 1, and check there is one sequence forming that you required Pi equals to 2, like at Pi equals to 2, that time you will get the R equals to 1, R equals to 2, sorry, R equals to 2. So this is the same pattern, you can observe that, like this is the sorry here 1, you can observe there is one pattern forming, like Q, when the Pi equals to 2, this is the 1, for 3 there will be 4 and this will be 3. Q3, Q4. So if we take PQ, Q3 equals to, at fourth, when, okay, my mistake, got it. I was not able to guess properly here. That here, to get 3 R as a 3, we required Pi should be equals to 4. Pi should be equals to 4. So here the answer will be 4. As a I equals P3, then Qi equals to 3, and there will be 3. So the P will which required is this one. So what we will do, we will check whether for first 2's counts is there or not. Like if 2's counts is there, like there exists any permutation where in which on second position 1 exists. So we already calculated by position. If it is 0, then there is no any point to go other. We will break and we will print the answer. If it is exist, what we will do, we will count plus, like answer plus, and then we will move that, like suppose 2 exists, then we will go to that side and we will check for 1, that for 2 at one position anything exists, like in this one For that, anything exists, count. If it exists, we will count plus plus and we will move forward. Similarly, we go for all the m's, and when there will be count 0 and we will come to reach, we will print the answer as answer and we will break. For everything, we will do this one and we will get the answer. So this was the logic and the answer. If you like my videos, please subscribe to the channel, and if you want any improvement in videos and explanation, please do comment. I will definitely take it and I will try to improve. Thank you.